Welcome to another Student Zone session here at Microsoft Build. I'm Francesca Lazzari and I lead the Education Cloud Advocacy team here at Microsoft. I know that we had a brief break from other sessions and I know that you have been learning a lot about GitHub, Visual Studio Code, C# and Python. And now it's the time actually to learn machine learning, AI, and how to apply these with art. So before we get started, I'd like to remind you that you need to review the Microsoft Digital Code of Conduct that is posted here in the chat. And we ask, of course, that you are all kind and respectful to everyone. So with all that being said, I'm very excited now to introduce this session. Dmitry is going to be the speaker, and I'm very, very happy about this session because somehow combine two things that I really like, that are, again, artificial intelligence and art. So please, Dmitry, welcome and let us know how we can learn more about machine learning, cognitive services, and how we can apply this to art.
Thank you so much, Francesca, and hello, everyone. I will talk about two of my favorite topics today. One of them is AI and art, and another one is how to get interested and how to learn programming in the fun and exciting way. The reason I'm interested in those two topics because my daughter, she goes to art school, and I also want her to get proficient in programming as well. So I always invent some ways which would be exciting. And I think learning programming in an exciting way is to be able to create something with your own hands. Because when you learn programming just by solving some problems, by printing something on the screen, it is very abstract and you do not always see the beauty of what you create. On the other hand, programming is such a discipline that you can create really beautiful things with algorithms. For example, this picture shown here is obtained using very simple program and very simple algorithm. You take a point somewhere here in the middle, and then we randomly select one of the three vertices of this triangle, let's say this one, and we compute the point halfway towards the vertex. And it would be like this one. And then again, we repeat this. We select randomly another point, we plot a point in the middle, and we continue in this way by randomly selecting a vertex, and we end up with this beautiful picture. And what's interesting, this picture is infinite. It is so-called fractal because if you zoom in, it would contain the same kind of triangular pattern all the way down to infinity if we plot long enough. In fact, there are many fractals that you can produce using very simple and very concise code. For example, this one, Minkowski fractal, we can imagine having a simple creature called turtle, which follows commands like turn left, move forward, and leaves the trace after itself. And by commanding this turtle to do some moves, we can obtain this fractal using, again, very short piece of code. And we can make it as detailed as we want by increasing just one number in this program. And it will go even deeper, producing even more complex and even more beautiful spiral. So to learn more about those things and to learn the language that we use to program this, Python, I encourage you to visit a short Python course, which is available at my GitHub repository. So you can, I will show you briefly how it looks like. So it is a GitHub repository with some Jupyter notebooks available in Russian and in English. So if you want to learn in Russian, you can also do that. So to be able to run this course, you need to be able to execute Jupyter notebooks. Jupyter notebooks, in case you don't know what it is, they look like this. They contain text and some Python code, which you can run to produce the result. But on GitHub, you can only look at it without being able to run it. If you want to run it, you need to have some executable Python environment. There are several options you can do that. You can install Python on your machine, which is definitely a good idea if you are serious about learning programming. I typically recommend to start with a distribution called Miniconda, but you can also use some others. And running Python with Visual Studio Code is a very convenient way to do it, and I will show you later how it works. However, if you want just to try this code without installing everything on your machine, there are several ways you can go. You can, for example, use a technology called GitHub Codespaces. However, this technology is available right now in the preview, so you would need to apply for it and wait until you get approved. But once you get approved, you can just from GitHub say, I want to open this repository with the code space, and or you can create a new code space, and it will create the executable environment available to you right from the browser. So right from the browser, you would be able to start this notebook and start running cells and getting the results. So for example, here is the simple function defined to compute Fibonacci numbers, and you can change the code, run it, and see the results. So that's a very good way to learn, because you can always tweak the code and get to understand it really deep. So, however, today I want also to talk about art, because programming is a very beautiful discipline. By writing code, you can create beautiful artistic artifacts, like this one, for example, or this one. And artists, there is a whole direction of art called science art, computational science art, which use computers to produce this kind of art. And artists, they use sometimes their own tools. And one of the tools that they often use is called processing. So processing is a language and a programming environment which contains powerful drawing commands based on OpenGL, so that you can produce really beautiful things. It's originally based on Java, but there is also a Python mode for processing. You can here see it on this website. So you can write those programs in Python. I will show you briefly how processing looks. So it's its own IDE, and you write your program here. You can see this is the relatively small Python program, and if you run it, it will produce this interactive piece of art. And yeah, if you run it again, it will take different random numbers and it will produce something different. So if you are interested in learning more generative art, then processing is a definitely good way to learn. And in addition to just the environment, it contains the site called openprocessing.org, where artists are encouraged to share their own creations. So you can see what other people are doing. And for example, there is the whole set of pieces of art, and you can click on any of them. For example, here is the one that I put on my slide, which takes a photograph. And from a photograph, it generates this interesting pattern of curves, which resemble the original image. It looks like very complicated, but if you switch to code here, you can always look how it works, go into detail, and understand the algorithm, tweak it in some ways. For example, put your own photograph here and make some more substantial changes and learn by doing that. So processing is really good way to start. However, today I want to show you something slightly different. I want to use artificial intelligence to produce a piece of art. And this is the idea that I had a while ago, when I looked at Microsoft Cognitive Services. Cognitive Services are pre-trained tools which allow you to execute some machine learning models in the cloud, which solve some real-world problems. So the beauty of cognitive services is that you don't really need to understand machine learning or artificial intelligence deeply. You just have the set of functions which you can call to get your job done. So to see what cognitive services are available, we can go to Microsoft.com/cognitive homepage. And here we have the list of all cognitive services. You see there are services related to language, to speech, and to vision. And because we want to do something with photographs, we are interested in the vision part. And there is a computer vision service, which just works with images, and specific service that works with faces. So let's have a look at how this face service works. It can take any picture, and here below we can see the demonstration. We can select any picture here. And on the right, we see the result of calling the service. So when I call the service as a developer, I get this information back. And you can see I have different information extracted from this picture. For example, I can see the different attributes of a face, whether it has hair or not, smile, gender, age, whether the person has glasses or not. So a lot of different things I can extract from the photograph. And what is the most interesting for our job today is I can extract facial landmarks, which is coordinates of the main points on the face. So here, the idea that I had a while back is to take a bunch of photographs of one person or different people, extract facial landmarks, and then align photographs automatically in such a way that eyes are at the same position. And by doing so, we kind of create the averaged out portrait of a person, because eyes are at the same position, we have eyes and everything around eyes clearly visible, but all the background kind of fades away because we have different backgrounds mixed together. So let's see how this can be done. I have the piece of code in Python that does that, which you can use, which I will go through now. And if you want, after this session, you can always go to this repository and create those cognitive portraits for yourself, for your friends, for your family. And I can give one hint. It works very well as the present. So for example, last New Year, I took pictures of my friends from Facebook. I created those portraits for them and printed out calendars, like wall calendars with their cognitive portraits. And that was really good present. So let's see how this works. I have this repository right here. So you can also go there and run it either using code spaces or Visual Studio Code and local Python environment, or you can also use Binder by clicking just on this button. That's probably the fastest way. I will open my Visual Studio Code with this notebook and go through this code step by step. So first of all, to call the cognitive service programmatically in the cloud, you need your Azure account. And here, I describe the steps that you need to get your Azure account. If you're a student, you can go and go to Azure for Students, or even better, to get GitHub Student Developer Pack, which gives you a lot of student-free resources. Or anyone can apply for Azure free trial. So that's another good option. Once you create your account, all Azure resources are available to you through Azure Portal, which looks like this. Here you can create different things, like you can create virtual machine, you can create a website, whatever you want. But in our case, I want to create the cognitive services endpoint. So I click create and I say cognitive services. So here I need to provide the name of the resource group, which is kind of directory where this would be stored, the location where the service would be, and I click create. I would not go through this to save time. I will show you the existing cognitive service which I have created just before this session. And it is pretty simple. The only useful thing here is keys and endpoint. To access the service programmatically from Python, you need to get this endpoint, which is the address at which we want to call this service, and we need the key, which is the sequence of numbers. So I copy the key and endpoint from here, and I put it into my Visual Studio Code here, key and endpoint. And then I need to execute this. So when I have this notebook, one important thing is to execute all steps one by one. So I skipped a few in the beginning because I have already executed them. But if you want to try it yourself, remember that all cells need to be executed one by one. Because here, for example, I install Cognitive Services SDK, and that is something that we need for the program to work later on. So once I have this key and endpoint, I can start running the service. So suppose I have a photograph somewhere in the internet. For example, this is the picture of me located at some website, at the conference website. I can then define the cognitive service endpoint, so-called, the cognitive services client. And then having the URL of this face, I just do one function call, this one, detect with URL, to get the required information. So you see, from the programmer's point of view, that is very simple. You just do one function call. You say, I want to get facial landmarks, and you get all those coordinates right away. You can also get other data here, like you can detect age and everything that we have seen before on the web page. Now, now that I know that how to extract coordinates, I can put my own photographs here. To do that, I need to put my images somewhere. If you are using your computer, just put them in some directory, for example, in this images directory under the project. If you are using code spaces or a binder or some other online technology, you would need to upload your photographs. I will take, for example, the photographs of me and my daughter like this, hoping that if I merge photographs of different people together, I would have some kind of mixed portrait which would represent our family in this case. So that is something that I want to do. The photographs should have face clearly visible. If you have many people on the picture, then probably you would need to select one of the faces for processing, but it's easier to start with the nice pictures like that. Also, it's good to have face like direction of head more or less the same, because if you look at the sides, then mixing those photographs would not produce good results. So going back here, once I have the images in this images directory, I can try to play with them. So here, for example, I open the first image, analyze it, and I plot all the facial landmarks over the face to make sure that it works. And you can see indeed that the facial landmarks, they correspond to real points on the face. So it means that technology, the cognitive service technology, is working, which is good. Now I need to go and for all photographs do this one by one. This piece of code does that. It's a simple loop. I will not execute it because I want to save time. The only thing I want to note is that I take 20 photographs here because I don't want to do more than 20 calls to cognitive service. Because if I'm using free version of cognitive services, I'm limited to 20 calls per minute. And if you do more than 20 calls, you would get errors. And that's why it's better to limit yourself to the number of pictures that you process. Also, having more than 20 images does not always produce good result because you are like averaging out too many things. So 20 is a good number. Let's see how those photographs look. I just have the small function here that displays a list of images. So I will take first 5 images from my array and I will display them. So that's how the source images look like. And now I am moving to the most interesting part. So the most interesting part is how to align them in the right way, how to move them so that eyes are at the same position. And to do that, I'm using the mathematical concept called affine transformation. So affine transformation is when you transform the image in such a way that you rotate it, you zoom it, you stretch it in different ways, but having parallel lines stay parallel. So you are not introducing any distortions. You are just like rotating, aligning the photograph and putting it in the right place. And in order to do that, like to define this affine transformation, we can start with 3 points. We can take 3 points and say, I want those 3 points to move to another 3 points. So having coordinates of 3 points, the source coordinates and target coordinates, that uniquely defines affine transformation. To play with images, to apply this affine transformation to images, I'm using the library called OpenCV. OpenCV is probably your first stop to go if you want to do any kind of image manipulations with Python. So here, what I do, I define the target 3 points somewhere inside my image. So I am fixing the image size to be 300 by 300. And then I say I want like left eye to move to this point, 130, 120. And this is kind of like selected by hand. So I figured that the eye should be somewhere like towards the top left of the screen, which is this coordinate. And then the right eye would be 170, 120. And the third point, I can select anything. But for symmetry, it's nice to select something which is like opposite to the eyes. And I have selected middle of the mouse, like this point here. Cognitive service does not give me this coordinate. Unfortunately, it gives me coordinates of the left of the mouse and right of the mouse. So I need to calculate this by averaging out the mouse left and mouse right coordinates. And I go over X and Y coordinates to do that. So then get affine transform is the function in OpenCV which does all the most complex part. I give it the array of source 3 points, which is pupil left, pupil right, and those computed coordinates of the middle of the mouse. And I want those 3 points to move to this target triangle, to the specified coordinates defined above. So this function, it takes image and the array of coordinates of different facial landmarks. And it returns the transformed image. You can see that warp affine applies the transformation to the image, and it also cuts the image to the defined size. So this is a very convenient function for us to use. So once I do that, let's see how it works. I apply this transformation to all my images. You see, I take my images and extracted points and apply images and extracted points inside affine transformation, and I get this result. So you can see that from the images above, it extracted like the face, and it put the face exactly in the same position. It might look a little bit off, but if you check, indeed, eyes are exactly at the same position. So now we only need to merge the images, and that is very simple to do in Python, because images are represented by matrices, by arrays, and merging them can be done with one operation in NumPy. However, I want to get a little bit more complicated than this, because in computer art, you often want to produce some variations of a picture just to select the good looking one. So I would add the ability to assign different weights to different images, and then I will randomly play with those weights until I get the good result. So my merging function looks a little bit more complex than just one line of code, but not very complex. So what I end up having is that I can merge two photographs. Here I show how to merge two photographs. And I end up having, you see, those photographs indeed superimposed on top of each other. And with two photographs, that's not very funny. Now I can just use this function to merge all aligned images to get the final cognitive portrait. Somehow it looks a little bit scary, but that's the result that we have. Now, as I mentioned, I want to add some randomness. So I will call this merge with different random vectors, and I will do it 5 times to get 5 different results. And let's see if we have something which is nice. Yeah, you see, those are slightly different. What you can also do, you can play with that. You can take, for example, not all images, but you can take like the first 5 images, and you will see that the result would be very different by aligning just 5 images. You can take 10 images, and you will get something like this. Also here, for example, you can say, I want to take 10 images, and here I want the length of vector to be 10. And you will see like more difference in the results because the number of images is smaller. So once you like the image you produced, you can save it using OpenCV. You can save it to disk into a JPEG file, and then with this file, like you can tweet about it, you can put it on your website, or you can print it out. If you want to print out this as a gift to your friends, like on a photograph, then probably you need high resolution image. And luckily, it's very easy to get high resolution image. You just need to tweak the resolution here. Instead of 300, make it higher, make it 1000, and also tweak the coordinates of the points here. So that is, I think, very nice technique, and you are free to take this notebook and play with it. And actually, just putting images on top of each other is the simplest idea that you can implement. But you can also try to implement something more complex, because you know that in art, there should always be some idea behind the thing that you do. And for example, I will show you one of the pictures that I have created last year from our family album. What I did, I took our family photo album and I processed it using cognitive services. Face API also allows you to match faces to people. So for example, I can upload in advance of several photographs of different people, and it will tell me like whose face it is. So I can easily extract just photographs of my daughter, just photographs of myself. What Face API also returns you, it returns you the angle of rotations of the head. So I can, for example, take only photographs which have the head looking straight. That's what I did. And then I like sorted the photographs of my daughter by age, put it into different buckets. And each bucket, so this one is like youngest photographs, and then a little bit older, and then at the right, the way she looks now. She's 17 now. And then I aligned them in this beautiful way, and I think that shows pretty nicely the way that she grew up. So I find it a little bit sad looking at this picture, but still, I think it's quite nice. There would be some problems when you do things like that, because, for example, when I did it originally, the picture was very dark because you put images on top of each other, but then there are black parts here, and you need to do something with that. But you know, there are no limits to what you can do with programming, so you can always express your idea in the form of code. So this simple idea that you can manipulate faces automatically using Face API, using cognitive service, can bring you lead to a lot of different ways to use this to produce art. But artificial intelligence is more sophisticated than that, because here we use the AI, but we used AI just to extract points on the face. And in fact, we could have used different technology. There are algorithmic ways to do that, which are less accurate, but which still work. However, you may have heard that artificial intelligence is capable of much more. It can even draw pictures by itself. And here on the slide, you can see the pictures produced by a neural network, which was trained on paintings. So I took the photographs of paintings from WikiArt collection, and I trained a neural network using Azure machine learning to produce that. So those pictures were flowers. Those were trained on portraits, and some of them were trained on landscapes. So three different sets of pictures. And having neural network look at those paintings for 11 hours produced a network which is capable of producing those images. So you can see that neural network produces something really similar to a painting, because it has those kind of artifacts here on the image. And but we can argue whether this is art or not, because it looks like a real picture. But the point is that artificial intelligence sometimes produces this, sometimes it produces something which doesn't look as beautiful. And you need a human being to understand what is good and what is not. The way neural network works, it doesn't want to draw something. It does not understand what it's drawing, because neural network is just a clever machine for multiplying matrices, and it just ends up producing the image. Neural network extracts patterns. It's very good at extracting patterns from images, from whatever data it sees. So what happens here when you train this network is that neural network learns first low-level patterns, like you see those canvas pattern and the way you put paint on canvas. Those kind of patterns are easiest to extract. And then it looks for higher level patterns. Like in pictures of flowers, there are a lot of colors in the middle. So it puts a lot of colors in the middle of those pictures. In portraits, it extracts the notion of the eye. It understands that pixels need to be aligned in such a way as to form something similar to the eye. And then two eyes need to be somewhere in the middle of the picture, aligned in a certain way. So neural network learns those patterns, and then it randomly puts them in canvas to produce the result, which sometimes looks beautiful. So you can say that artificial intelligence does a lot of in producing those pictures, but does it randomly. In the same manner, many artists, they just do random splits of paint on canvas and then try to make picture from those, because people need inspiration, and sometimes inspiration is random. So I think the point is that by working together with artificial intelligence, by using artificial intelligence as a very, very powerful tool, artists can do much more. And that is something I encourage you to do. If you are into development, try to get inspired by artistic things. If you are an artist, try to use modern technology to make your works more powerful. And I think the things that artificial intelligence does, they are pretty amazing. I think that's really amazing that computer can do things like that.
Thank you so much, Dmitry. I have to say was a really, really great session. I have been always very passionate, as you know, about machine learning, AI, Python, but I never learned how to apply all those concepts, all those technologies to art. And in particular, I really enjoyed the part where you introduce cognitive services, that these are pre-trained models on the cloud. So it sounds that is something very, very helpful for people who want to also get started with AI and machine learning. So thank you so much again for this fantastic session. I do have some questions for you. Like there is a person asking from the audience, more like a general question. Do I need to know probability and statistics to learn AI and machine learning?
That's a great question. I think you can start definitely without knowing statistics. If you are a software developer, then you can just use existing models, or you can just use existing code to put things together, because typical problems, they have been solved, and you can definitely use the same ideas applied to your own problem domain. But if you want to create new neural network models, if you want to get really deep into this subject, then of course mathematics is something that you really need. And from mathematics, indeed, probability and statistics, linear algebra, and calculus, those are most important areas of mathematics that are used in deep learning.
Yeah, I totally agree. And then another question that I had, so can you use the same code, the same technology to create portraits of cats, for example?
Oh, that is a really great question. The problem is that here I use the cognitive service to extract facial landmarks, and cognitive services, they are trained on pictures of people, so it can only be used for people. And if you want the same idea to be applied to pictures of cats, you need somehow to extract those landmarks, facial landmarks for cats. And you would need to either train your own neural network model to do that, and for that you would need the data, like thousands of pictures of cats with marked eyes, or you can try to use computer vision techniques, but still it will be more sophisticated than just calling the pre-trained model.
Yeah, I understand. So there is a lot of potential with using the pre-trained models, of course, but you need to use the same typology of data, more or less. And so I also have another question. You have been talking a lot about art in general. So can we use this technology inside the museum? So where, you know, most of the time we can find art, but with live photographs of people. Do you need internet connection in that case?
Yeah, because we are using cognitive service, we need to call the service from the cloud. And in fact, this scenario is something that I have also implemented. Last year, when museums were still open, I created the small exhibit for one of the museums in Moscow, and it did exactly what is proposed in this question. Like, it took photographs of people passing by, and it combined them together into a live averaged portrait of the museum visitor. And the way it worked is, when it had internet connection, it called the cloud. When it didn't, it used less accurate local model to do the same, so that it was still live but not producing as good results. However, what you can also do, you can also use cognitive services as container models. So you can download this actual model to your local computer and call it, and it still needs a connection to the cloud, but it just sends the information, like how many images were processed, but not actual images, which reduces the internet connection requirements. It can be like very slow connection, but it will still work.
I see. Very, very interesting. There is another great question from the audience. So, what technologies should I use in order to get started with AI? Is more about learning Python, or is more about learning cognitive services? What's your suggestion, Dmitry?
Well, I think you should learn Python anyway, because having a programming language opens up a lot of possibilities. You can try to use AI without learning to program. For example, there are some tools which can do it like interactively, visually. You can use AutoML, or you can use Power Apps to do something, but learning how to program is a very important skill here. So learning Python is a really great option. And then you can start with calling cognitive services. That's definitely something not very complicated, as you have seen today. And after that, when you feel the limitations of cognitive services, you can try to advance into using existing pre-trained models, or into training your own models. Because even though it is more complicated, but still it's not rocket science. Now there are a lot of problems that have been solved already. For example, if you want to classify images cats from dogs, there is a cognitive service for that, but you can also use existing like tutorials and train the model to do that. And that is something like quite typical. Just remember that to train something for machine learning, you need data. So that is, I think, one of the big problems, where to get data for your specific tasks. Like for recognizing pictures of cats, like where do you get the data set of cats?
Yeah, so this is a great, I agree with you. So cognitive services is not just a great help for the models, the machine learning models themselves, but also for the data. And it's a great way to get started. So this is all fantastic. Do you have any additional resources to share with the audience today so that we can learn even more about AI, machine learning, and art?
Definitely. So first of all, this tutorial that I have shown you on creative cognitive portraits, it is available as a blog post. So if you want to read about it in more detail, and like follow all the steps with description, you can have a look at this blog post. Then also I have very interesting post about creating this exhibit for the exhibition, which put portraits of people passing by together. And this post is very interesting because it combines different cloud technologies. For example, to capture image, I use .NET and local face recognition on the client. And then I send it to Azure function inside the cloud, which draws the portrait, and it uses different types of storage. It calls cognitive service from within the cloud. So if you are interested in to see in more detail how cloud can be used, different cloud services can be used together to produce a complex system like that, that would be a great place for you to work. Finally, those generated pictures that I have shown you, how to train a neural network to do that. I also have the blog post on that, generating images on Azure Machine Learning. And finally, this whole idea of whether AI can be creative or not, should we consider this to be like machine creativity or not, or just a tool? It is also described in the blog post. So there is a lot of interesting reading I created around this idea. And then if you want to learn Python, I have shared already the course on Python. And if you want to learn more about using Face API, you can see Microsoft Learn module on Face API. In fact, Face API can be used from other programming languages as well, not only from Python, because it is a REST service. Like all cognitive services can be called through the internet from any programming language. So if your favorite language is not Python, you can definitely do that. It would be more complex to do things with images, like in this example I have used OpenCV, which is very powerful. But if you just want, to detect people, classify people, then you can use C# or any other languages. So I think those are the main resources. And if you have any feedback, if you come up with new ideas on how you can use Python to create something artistic, please feel free to get in touch with me. I have my own website with contact information. I have Instagram, and also if you want to see more of images produced by neural network, I have also another Instagram, Art of Artificial. It's not updated very often, but sometimes I put the new images produced by a neural network.
Well, I will really check it out because I really want to learn more about neural networks and art. So Dmitry, thanks again for this fantastic session. We really learn a lot from you. So our next session in the student zone will start in just 15 minutes, so don't go far. My co-worker Jasmine will help you continue building your C# skills, and will walk you also through how to build your own bot, which is extremely important nowadays. So please make sure that you have it on your calendar and you can join. Just a couple of reminders before we wrap up. Don't forget to fill out the survey for this session. You can find a link to the evaluations at the bottom of this session page, and you can also just use the My Evaluations link on the Build site. So please let us know what you think. And second, make sure that you go and check out the Cloud Skill Challenges. There is one specifically designed as an intro to developer skills. It's called the Dev Mixtape Volume 1. So you can sign up through the link on the Learning Zone page, and then you can also be entered for a chance to meet with our product leaders, which is a great opportunity to learn more about coding, products, and also machine learning and AI at Microsoft. So thank you everyone for joining us. Enjoy the rest of Build.